All right, this video is about compound events, and in it we're going to find the probability of mutually exclusive events as well as the probability of inclusive events. And here is some of the vocabulary that we are going to cover. So let's jump right in. A simple event is an event that describes a single outcome. The probability of A, that's a single event. A compound event is made up of two or more simple events. Probability of A and probability of B. Mutually exclusive events are events that cannot both occur in the same trial. So if they cannot happen at the same time, they are mutually exclusive. Rolling a 1 or a 2 on the same roll of a dice are mutually exclusive events. Because you can't roll a dice and get both a 1 and a 2 at the same time. You can get one or the other. Mutually exclusive. So, remember we have our symbols for or and. Remember that the symbol for union is this U, which means or, either or, from our Venn diagrams. Now, if you have this or, what you're going to do for today's lesson is to add. The or tells us that we should add. If you're trying to find the probability of event A or event B, then you have to add the probability of A plus the probability of B. Now let's compare that to what we had learned previously. We learned about the and symbol, the mountain one here. And whenever we have that the and means to multiply. So if we had the and, if you wanted to find the probability of event A and B, you would add. But if you want or, the probability of A or B, you have to add. So example, a group of students is donating blood during a blood drive. A student has a 9 out of 20 probability of having type O blood and a 2 out of 5 probability of having type A. Explain why events O and type A blood are mutually exclusive. Okay, well, they're mutually exclusive because they cannot both happen at the same time. Either you have type A or you have type O. A person can only have one blood type, so they are mutually exclusive events. What is the probability of having O or A? When they want us to find the probability of having one or the other, we have to add the probabilities together. So we're going to add the probability of O plus the probability of A. The probability of O or A is 9 over 20 plus 2 over 5, which gives us 17 out of 20. Inclusive events are events that have one or more outcome in common. So when you roll a number cube, the outcome rolling an even number and rolling a prime number are not mutually exclusive, which means the circles overlap. Inclusive events means that there's something that can happen and it can be in both events at the same time. For example, if you roll a 2, that's an even number, and 2 is also a prime number. So the number 2 is in both events. That means that these two events are inclusive. They overlap. So there are 3 ways to roll an even number. You can roll a 2, a 4, or a 6. There are also 3 ways to roll a prime number. You can roll a 2, a 3, or a 5. Well, if we had asked you to find an even number or a prime number, you would add them together. But the problem is that the outcome 2 is counted twice when the outcomes are added together. So when you add the 3 and the 3, you would end up counting the 2 twice. So we have to subtract that out. The actual number of ways to roll an even number or a prime number is 3 plus 3 and then minus the 1, which gives us 5. The concept of subtracting outcomes that are counted twice leads us to the following probability formula. Okay, so we know or means to add. When you are trying to find the probability of two events that are inclusive, the probability of A or the probability of B equals the probability of A plus B minus the place where they overlap, A and B. And just as in our example here, even numbers was 3 out of 6, prime numbers was 3 out of 6, but then we had to subtract off the 1 out of 6 for the number 2, which was where they overlapped. Okay, so when you are adding, don't forget to subtract if the events that you're adding both happen at the same time. So if we have like the two circles and we're trying to find the probability of the green circle plus the probability of the blue circle, you have to subtract out the place where the two circles overlap. Find the probability of rolling a 4 or an even number on a number cube. So the probability of 4 or even equals the probability of 4 plus the probability of even minus the probability of 4 and even. So since 4 is also an even number, we're going to have to subtract that out. We have the probability of 4 is 1 over 6 and even 3 over 6. We can subtract out the 1 over 6 where they overlap, giving us 1/2 for our probability. Okay, what is the probability of rolling an odd number or a number greater than 2? Well, that's going to be the probability of odd plus the probability of greater than 2 minus the place where they overlap, odd and greater than 2. So there are two outcomes that fall into both categories. We could roll a 3, that's odd and greater than 2, or we could roll a 5. So 3 and 5 are both odd and greater than 2, so we're going to have to subtract those two out. Probability of odd is 3 over 6. Greater than 2 is 4 over 6, and then we have to subtract out those two, which gives us 5 over 6 for our probability. All right, and last example of 1,560 students surveyed, 840 were seniors, and 630 read a daily paper. The rest of the students were juniors. Only 215 of the paper readers were juniors. What is the probability that a student was a senior or read the daily paper? And I think we should do a Venn diagram to show what the numbers that we have here. So let's label it what we know in the Venn diagram. We know that 215 were juniors, of them were juniors. We know we had a total of 1,560, and the seniors are 840, and paper readers, the paper reader total was 630. So now we can subtract. If we subtract the 215 from the 630, we can have the 415, which is where the circles overlap. And then we're using the number of seniors. We can also find the number of seniors here because we know the total number of seniors that should make up that whole circle. So we can also subtract there it goes, and we get 425 for the number of seniors who did not read the paper. So senior or paper reader is going to equal the probability of senior plus the probability of paper minus the place where they overlap. So senior total was 840. Reads paper total 630, and then we have to subtract out the 415 where they overlap to give us our total probability. The probability that a student was a senior or reads the daily paper is about 67.6%. Okay, there's our Venn diagram. All right, so in this lesson we learned that a simple event is a single outcome, compound events are two or more simple outcomes, and the more important vocabulary for this one, mutually exclusive events cannot happen at the same time, whereas inclusive events have something in common. They overlap. Okay, great.